This tutorial will describe the general usage of the submarine and Fig7 TMA displays. For detailed information on TMA and all other components of the game, we encourage you to consult the manual. TMA, Target Motion Analysis, is the technique used to determine range, course, and speed of a contact based on periodic contact bearing information provided from shipboard sensors, commonly referred to as bearings-only TMA. For this tutorial, we will use the SSN-21 class submarine's hull-mounted passive broadband sensor to provide the contact information, lines of bearing. All AI crewmen have been turned off. Assigning a sonar tracker to a contact means that the system will display updated bearing information every 2 minutes on both the navigation screen and the TMA display. Here on the navigation geoplot, the bearing to the contact is displayed, but the range to the contact is unknown. The length of the bearing line has no meaning and does not imply any range information. This is the TMA screen. This is where the sonar tracker will display the bearings for the selected tracks. Let's first select track Sierra 1 to show the bearing for the contact to the north, and then select Sierra 2 to show the contact to the south. Let's go back to Sierra 1 and move forward several minutes until there are several LOBs on the display. The ruler, or speed strip as it is sometimes referred to, is manipulated to generate possible TMA solutions of range, course, and speed. For LOBs displayed, there are an infinite number of solutions that fit the data. Fitting the data means that each tick mark on the ruler lines up with the LOB. The small plot in the upper left corner graphically displays the bearing difference between the ruler tick marks and the LOBs. A perfect solution stacks all the dots on the center line. Any information that helps narrow down one of the 3 parameters, range, course, or speed, can be used to help find a TMA solution. Geography may help with limiting the range. The direction of bearing drift will limit possible courses, and target classification or demon analysis may help with speed estimates. Speed estimation using the demon display is fully described in the user's manual. Now assume through demon analysis that a speed estimate of 10 knots has been made. A 10-knot speed can be locked in, and the ruler can then only be manipulated for range and course. The line of sound is the current bearing line between own ship and the contact. If both own ship and the contact's courses are on the same side of the line of sound, then the tactical situation by own ship is a lead situation. If the 2 courses are on opposite sides of the line of sound, then the situation for own ship is a lag condition. For a lag situation, the crossed LOB range is a minimum range. For a lead situation, the cross bearings present a maximum range. One way to determine whether a lead or lag situation exists is to point the contact and observe the bearing drift. In this case, the bearing is drifting to right, so the original situation was a lead. Continuing the course change will set up a lag situation and produce a minimum range of cross LOBs. The new own-ship course, or TMA leg, will help narrow down possible TMA solutions that satisfy data from both TMA legs. TMA is as much art and puzzle solving as it is science. Use all available information to help estimate the 3 unknown parameters, range, course, and speed. Use the mission editor to set up practice TMA scenarios. Also, turn on your TMA auto crew and observe how he converges on a TMA solution. The FFG TMA display, though similar to the submarine TMA displays, does have some differences. The FFG TMA display represents the DRT, Dead Reckoning Tracer, that is found on the Fig7 class frigate. The DRT is a light table with tracer paper where crewmen manually draw LOBs and manipulate speed strips or speed rulers to generate TMA solutions. The DRT cannot be panned. Repositioning the light bug means starting over on drawing the LOBs. That concludes our TMA tutorial. Please consult the manual for additional details employing TMA in the game.